Hi guys, this is Sangeetha. I'm here to explain a project based on pain detection from facial images using unsupervised learning approach. Be patient and watch till the end. Aim of the research: to analyze the level of pain using facial emotions, to minimize the presence of caretakers for patients in the hospitals. Literature review: we have gone through 4 papers for our reference. Those papers helps us by giving some valuable points. Some flaws has been highlighted. Inadequate training data and unsuitable pain annotations. Doesn't give specific timing information. Medical personnel involved in pain management and no accurate objective measures. Again, no validated objective measures of pain. Proposed architecture: training image has been stored in database and testing image is given as input, which contains facial image. Some of the pre-processing techniques used here are resizing, filtering and enhancement. The two algorithms used here are PCA and LDA. To control the noise produced, we are using MSc PSNR module. Finally, the result will be displayed in a message format to the caretakers and doctors. Modules: there are 5 modules in our project. Those are resizing and filtering, adaptive histogram equalization, principal component analysis, linear discriminant analysis, and finally MSc and PSNR module. Here we have attached the screenshot of menu containing some categories like training the database, test input, pre-processing, edge detecting, contour tracing, result and exit. After training the datasets into the database, the results will be like this. Moving on to module 1. It consists of resizing and filtering. Resizing the image consists of 3 processes called resampling, image interpolation and cropping. Gabor filtering undergoes texture analysis and feature extraction. Resizing of image: the pixels of the input image will get added or subtracted. The width and height of the image gets increased or decreased accordingly. Image interpolation has been carried out, which is zooming out the image to increase the quantity of pixels. Cropping takes place whenever a part of image is not needed. File size is also reduced, which is handled by compression techniques, lossy and lossless. Filtering: we use Gabor filter here for feature extraction. It is nothing but the characteristic of a feature being observed. It is also used for texture analysis, that is face separation or testing image. Process involved in Gabor filter: a grayscale image is given as an input to the filter, which produces an output in the form of complex numbers, which gives us magnitude and phases. Enhancement: enhancing the image helps us for further image analysis. Removing the noise, sharpening and brightening an image, identification of key features are done by this module. Sharpening includes boundaries and edges and increases the contrast. After pre-processing the image, the filtered image will be like this. Moving on to second module, adaptive histogram equalization. Before moving into AHE, a knowledge about histogram is needed. It is nothing but a graphical representation of the tonal distribution in digital image. It graphically represents the different tonal colors like light purple, dark purple, etc. These colors are always opposite to contrast colors. Histogram equalization is a method of contrast adjustment and also reduces the noise in some homogeneous region of image. Adaptive histogram equalization is slightly different from histogram equalization. It adapts to histogram equalization method and redistributes the lightness value of the given image. Image intensity is also adjusted to enhance the contrast. The output will be an highly contrasted image. Moving on to Module 3, Principal Component Analysis. It is a dimensionality reduction technique used in machine learning applications. Transformation occurs and linearly correlated variables get transformed into uncorrelated variables. By using this technique, redundancy can be reduced. These are the steps involved in principal component analysis. Loading the input image data. Data exploration helps us to cut down the massive dataset to a manageable size. And data standardization brings the data to a common format, just 2D to 3D or 1D. PCA transformation, graphical representation, data compression and dimensionality reduction technique. The eigenvalues and vectors computation are performed. It involves arranging the principal components. And the sixth step is validation of PC, checking whether they are able to reduce redundancies or not. And finally, converting the principal components to an image format. Here a sample is attached for principal component analysis. Moving on to Module 4, Linear Discriminant Analysis. It is also a dimensionality reduction technique and is similar to PCA. It gives us the difference between the classes of data and also class labels. It is one of the easiest methods for categorization of data. It mainly focuses on maximizing the separability among the known categories. For best decision making, we use both principal component analysis and linear discriminant analysis algorithms. Contour tracing. It is also known as boundary tracing, which identifies the boundary pixels of a digital image. Here you can visually see this. Moving on to Module 4, MSE and PSNR. The abbreviated is mean square error and peak signal to noise ratio. It is a method for removing the noise produced during compression state. We use this formula for calculating peak signal noise ratio. If the ratio value is high, it indicates that the signal is of higher quality. Edge detection. Outer edge of the given image is detected. This will be the result. The pain level will be displayed after performing all the above mentioned operations. And finally, future enhancement. Hence, our project produces 88.4% accuracy in recognizing